Okay, today we're going to be graphing systems of inequalities. So we're going to be graphing each inequality, shading it, and seeing where the shading is overlapping. I recommend that when you do this, you use two different colors. It makes it a little easier to see where the shading is overlapping. Sometimes you will not have an overlapping area. So if there is no overlapping area, there is no solution. So we will see an example of that here in a moment. So I'm going to graph my first inequality for number 1. So I'm going to start at 1. My slope is -2, so down 2 over 1. You can make as many dots as you want. And this would be a dotted line. Since it's just greater than, there's no equal to part that goes with it. And then since it's greater than, we're going to shade where numbers are greater than. As a reminder, you can also test a point. So you could test 0, 0, plug in 0 for your numbers. -2 times 0 is 0, plus 1 is 1. 0 is not less than 1, so you do not shade where 0, 0 is. So here 0, 0, shade where it is not. Now with a different color, I'm going to graph my other inequality. So start at 3. Slope is 1, so we go up 1 over 1. And then this one is going to be a solid line. And it was less than, so we're going to shade where numbers are less than, so right here. So then, since we use different colors, we can see the overlapping area is this area right here. So your solution or your answer could be anything in this area. So if I were to ask, is 0, 5 a solution? So 0, 5 is right here. That would be no, because it is not in the double shaded area. If I ask, is 2, 1 a solution? 2, 1 would be about here. Yes, because that's in the shaded area. Okay, number 2, y is less than or equal to 3. So I'm going to have a solid line going through y equals 3. That was less than, so we shade down here. And then for your other line, you need to get y by itself, so I'm going to subtract the x to the other side. So my y-intercept is 1, go down 1 over 1. And this is also going to be a solid line. And this one is shading up because it says greater than. So shade this area. So my area that got double shaded is right here. So again, here 0, 0 would not be a solution because it's not in the double shaded area. But say 3, 1 is, because that would be in the shaded area. Okay, moving down to number 3. Okay, for number 3 we have to get our y by itself, so I'm going to write that down here. We're going to subtract the 3x to the other side to get negative 3x plus 2. Change all of your signs, but when you change your sign, you also need to flip your inequality symbol, because remember, that's like dividing by a -1, and when you multiply or divide by negative, you flip your inequality symbol. So I'm going to start at -2, go up 3 over 1. This is going to be a solid line. And it says less than, so we're going to shade this side. And then your other point, or sorry, your other line, again subtract the 3x to the other side. Then change all of your signs. So I'm going to start at 5. Now you can go up 3 over 1, but that's off the graph, so we can also go down 3, left 1. And then this is going to be a dotted line. And it says y is greater than, so that's right here. So I see there is no overlapping area, so this is no solution. Okay, number 4, get y by itself, so we're going to subtract the x to the other side to get y is greater than negative x plus 2. So I'm going to start at 2, go down 1 over 1. This is going to be a dotted line. And it says greater than, so we're going to shade this part. Then your other equation that's going to have a bit more work to solve. So I'm going to move the 2x to the other side. divide everything by 2. Okay. So we're going to start at 4. We could go up 2 over 1. We can also go down 2 left 1. And this one's going to be a dotted line. And it says less than, so less than would be right here. So your double shaded area is right here. Okay, so this goes back to a few chapters ago, so hopefully you remembered it. If you have any questions, please let me know.